Hello everyone. Welcome to our channel. Today, we're going to take a look at simultaneous equations. Simultaneous equations are two equations that share variables, and we solve them at the same time. For example, you might have two equations with both x and y, and you're looking for values of x and y that work in both equations. There are three main methods to solve simultaneous equations: elimination, substitution, graphical. We'll cover the substitution method in another video. Elimination method. The elimination method involves adding or subtracting the equations to eliminate one of the variables, making it easier to solve for the other. Example 1. Solve. 5x plus 6y equals 8. 2x minus 6y equals 20. In this example, notice that one equation has plus 6y and the other has minus 6y. The plus 6y and minus 6y parts are exact opposites. What can we do to eliminate them? By adding them, they cancel out. Step 1. Add the equations to eliminate y. 5x plus 6y plus 2x minus 6y equals 8 plus 20. Now, we're left with 7x equals 28. That's much simpler. Now we can solve for x. X equals 4. Step 2. Substitute x back into one of the original equations. Let's use 5x plus 6y equals 8. 5 times 4 plus 6y equals 8. 20 plus 6y equals 8. 6y equals 8 minus 20. 6y equals minus 12. Y equals minus 12 divided by 6. Y equals minus 2. By spotting those opposite terms and adding the equations, we quickly eliminated y and made the problem much easier to solve. 2. Solve. 3x plus 2y equals 10. 3x minus y equals 1. Notice how both equations have 3x. What if we try to get rid of x and focus on y? How do we eliminate x? Step 1. Subtract the second equation from the first to eliminate x. 3x plus 2y minus 3x minus y equals 10 minus 1. 3x plus 2y minus 3x plus y equals 9. 3y equals 9. Y equals 9 divided by 3. Y equals 3. Step 2. Substitute y back into one of the original equations. Let's use 3x minus y equals 1. 3x minus 3 is equal to 1. 3x equals 4. X equals 4 over 3. 3. Solve. 3x plus 2y equals 16. 2x minus 3y equals minus 1. Notice, the numbers in front of x and y don't match up. We can't just add or subtract the equations to make x or y disappear. Let's see how to solve this. Step 1. Let's make the multipliers match by multiplying each or any equation so that either x or y will cancel out when we add them together. Multiply equation 1 by 3, 3x plus 2y equals 3, 16. Expand, 9x plus 6y equals 48. Multiply equation 2 by 2, 2x minus 3y equals 2, minus 1. Expand, 4x minus 6y equals minus 2. Step 2. Add the equations to eliminate y. 9x plus 6y plus 4x minus 6y equals 48 plus minus 2. 13x equals 46. X equals 46 over 13. Step 3. Substitute x back into one of the original equations. Let's use 3x plus 2y equals 16. See details as shown on screen. 4. Solve. 2x minus y equals 7. 3x minus y equals 10. Notice how both equations have minus y. What if we try to get rid of y and focus on x? How do we eliminate y? Step 1. Subtract the first equation from the second to eliminate y. 3x minus y minus 2x minus y equals 10 minus 7. 3x minus y minus 2x plus y equals 3. 3x minus 2x equals 3. X equals 3. Step 2. Substitute x back into one of the original equations. Let's use 2x minus y equals 7. 2 times 3 minus y equals 7. 6 minus y equals 7. 6 minus 7 equals y. Minus 1 equals y. Y equals minus 1. The elimination method is efficient for equations where variables can be matched up easily, and it's a common method in GCSE exams. Graphical method. The graphical method involves plotting both equations on a graph. The point where the two lines intersect gives the solution to the simultaneous equations. Example: 2x plus 3y equals 13. X minus 2y equals minus 4. Step 1. Rearrange each equation into the form y equals mx plus c, make y the subject. For the first equation, 2x plus 3y equals 13. 3y equals 13 minus 2x. Y equals 13 minus 2x, divided by 3. For the second equation, x minus 2y equals minus 4. 4 plus x equals 2y. 4 plus x, divided by 2 equals y. Step 2. Plot both equations on a graph. Step 3. The point where the two lines cross is the solution. In this case, the intersection point is 2, 3. The graphical method is useful for visualizing solutions, especially when equations are simple and the solution is a whole number. It's also a great way to check your answers. Word problem example. Let's see how simultaneous equations can help solve a real-life problem. Problem. Imagine you're at your favorite cafe. You order 2 coffees and 3 cakes, and the bill comes to £9.95. Next time, you just fancy 1 coffee and 4 cakes, and this time you pay £10.35. But wait, how much does each coffee and each cake actually cost? Let's solve this together. Let x be the price of 1 coffee, in pound, and y be the price of 1 cake, in pound. We can write 2 equations. 2x plus 3y equals 9.95. X plus 4y equals 10.35. Notice, the numbers in front of x and y don't match up. We can't just add or subtract the equations to make x or y disappear. Step 1. Let's make the multipliers match by multiplying each or any equation so that either x or y will cancel out when we add them together. Multiply equation 2 by 2. 2x plus 4y equals 2, 10.35. Expand. 2x plus 8y equals 20.70. Step 2. Subtract the first equation from this new equation to eliminate x. 2x plus 8y minus 2x plus 3y equals 20.70 minus 9.95. 2x plus 8y minus 2x minus 3y equals 10.75. 5y equals 10.75. Y equals 2.15. Step 3. Substitute y back into one of the original equations to find x. Let's use x plus 4y equals 10.35. X plus 4, 2.15, equals 10.35. X plus 8.60 equals 10.35. X equals 1.75. Final answer. The price of 1 coffee is £1.75. The price of 1 cake is £2.15. This example shows how simultaneous equations can be used to solve everyday problems involving prices and quantities. Remember, always check your answers by substituting them back into both equations. Label your equations and show you're working for method marks in exams. Please share your thoughts or questions in the comments section. Thanks for watching. Learning Maths the Easy Way. See you in the next video.